Hello everyone. Welcome back to my channel. Today we're excited to explore half adders. If you're new here, consider subscribing and hitting that notification bell so you won't miss any of my future Verilog tutorials. Before we get into details, let's understand what a half adder is. In digital electronics, a half adder is a fundamental building block used to perform simple binary addition. It takes two single-bit binary inputs, adds them together, and produces two outputs, the sum and the carry dot. To understand the behavior of a half adder, let's take a look at its truth table. As you can see in the truth table, there are two input columns for A and B, representing the two binary digits we want to add. The sum column displays the result of the addition, while the carry column shows the carryout generated during the addition process. We can express the sum and carry outputs using simple equations. The sum is the bitwise XOR of the two inputs A and B. The carry is a bitwise end of A and B. Let us write the Verilog code for the half adder. Create a folder and name it half adder and open the folder on Visual Studio Code. Create the half adder file.v. Now let us write the code for the half adder module. Do not forget to save your work. Let's create the half adder testbench file.v. The link for the code is provided in the description below. Let us go ahead and open the simulation to observe the waveform. Follow the instructions on the screen to open gtkwave. Go to File, open New tab, and choose the .vcd file. When A and B are 0, the sum is 0 and carry out is 0. When A is 0 and B is 1, the sum is 1 and the carry is 0. The waveform shows the expected behavior of a half adder.